Welcome to the Lionhearted Academy. This is Richard Tai, and today we're continuing our lessons on trigonometry. Today, as you can see, we're continuing talking about our graphs of trig functions. Now, yesterday, the previous lessons, we have tried to discuss a little bit about how the graphs of sine come about. So here, this is the basic setup again, but today I will go ahead and try to show you some other visualizations from the website, from the internet, that you can also use to help you understand how graphs of sine and cosine functions come about. Alright, so today let's go ahead and talk about cosine. So let's let the y value represents cosine of x. So x in this diagram represents theta. So in this diagram, the x and y are the x coordinates, are the coordinates for cosine theta and then sine theta. If you remember, cosine always represents has to do with x, and sine theta always has to do with y. So this is a basic unit circle that we're going to use to help us develop the values of cosine and sine theta. As theta rotates from 0 degrees, from 0 radian onwards, and as theta progresses from 0 all the way to go through 2 pi and continue going on through the real number axis. So we're going to be using radians rather than degrees. Again, so this is 0 radian, pi over 6, 30 degrees, pi over 4, 45 degrees, pi over 3, 60 degrees, and pi over 9, pi over 2, 90 degrees, and so on. Pi 180, 3 pi over 2, 270, and 2 pi 360. And the rotation actually keeps going, and it can go backward as well. But that's something else we'll later on discuss. So let's take a look at what cosine values start with. So when theta is equal to 0, cosine is 1. So that means when x value here on this graph, we're going to plot when x is equal to 0, cosine is going to be equal to 1. So we're going to put a dot 1 here. Okay. And the next one is square root 3 over 2 when pi over 6. Now pi over 6, this is pi over 2, right? This is pi over 4, it's half of pi over 2. Pi over 6 is a little bit before that. Pi over 3 is a little bit after that. Okay. So it's like that. So square root 3 over 2, yesterday we talked about, if you can try to put in a calculator, it's about 0.8. So 0.86, so very close to 0.9, and pi over 4 is 0.7, and then pi over 3 is 1/2, and then pi over 2 is 0. So it goes down like that. So as we can see, the cosine graph initially goes from 0, and gradually there's a slope, is a curve, it curves down back to 0. Alright, what happened in the second quadrant? What happened between pi over 2 and pi? Alright, let me just mark a few markings here. So in the middle, this is the reflection of pi over 4. So in the middle, it will be a negative square root of 2 over 2. This will be negative 1/2, negative square root 2 over 2, and negative square root 3 over 2 for cosine. And then we'll go down to negative 1. So I know it will go down to negative 1 at pi. Alright, the first one, it will go down to negative 1/2, then negative square root 2 over 2, so it's like negative 7, and then negative 0.86. So it will be the same kind of curve, but it will go in the negative direction. Then what happened in the third quadrant? In the third quadrant, it's still negative. The cosine value is still negative, but as you can see, it's coming back up. So it's going to be like kind of reflection of this part. And then at 3 pi over 2, it returns to 0. And then what happened at 2 pi? Well, 2 pi, it goes back to 1, right? At 2 pi, it goes back to 1. So here, it goes to positive. It goes to positive. It goes to positive 1/2, positive square root 2 over 2, and positive square root 3 over 2. So positive 1/2, positive square root 2 over 2, 0.7. I'm trying to. So therefore, now we can trace this. It's not going to be perfect because my graph is kind of off. But okay, I'm trying to do this a little better. And it will come back up here. So this is a basic graph of a cosine, and what will happen afterwards? It will keep going on. It will it will repeat the values. See, once you pass 0, once you pass 2 pi, you're going back to this angle, going back to this angle. So the values will repeat. So this graph will just keep going on like this, and it will go on like this forever. So that's why sine, cosine values, cosine functions, they're actually called periodic functions. So we'll deal with the vocabulary now later on. Periodic functions, because it repeats in a certain given time, in a certain amount of time, a certain time period. It will repeat itself. It will complete all the unique values in a certain period. In this case, the period would be 2 pi, because from 0 to 2 pi, about 6.28, the cosine function goes through all the unique values and then starts repeating itself. Okay, all right. Now let's take a look at some websites let's take a look at some websites from the internet, and then see how they demonstrate this using animations. Alright, so this is a website from, as you can see, web.calstatela.edu. Okay, it's a curved bank unit circle. So as you can see, it has two graphs. On the top here, it illustrates what the sine graph looks like, how does the sine curve becomes. So as you can see, this is the unit circle. Okay, as the angle, the blue is the angle, also equal to the arc in this sense, and the red is the y segment. Remember the y segment? So as the angle progresses, the y segment increases starting from 0. The sine value start from 0, go up to 1, come back to 0 at 3.14 at pi, and then goes down to the negative and complete cycle and come back to 0 at 2 pi. So that's how sine functions develop. But look at the cosine. Cosine starts develop in the same way, but it starts at different places. At 0 degree, cosine starts with 1, and it reduces down. At pi over 2, it goes to 0. At pi, it goes to negative 1. At 3 pi over 2, it comes back to 0, and then comes back up to 1 at 2 pi. So cosine and sine, they both have the period of 2 pi, because they all repeat themselves. They all complete the one complete rotation in 2 pi. So the period is 2 pi, but their starting point and ending point are different. So there's a certain shift involved between the cosine and sine. Also, if you notice something called the amplitude. Amplitude is the height, the maximum and minimum value, or the absolute value of this graph. How much does the graph go up and how much the graph goes down? How much does the graph swing up and down? Well, it's 1 unit above and 1 unit below the median value here, the average value. So as you can see, the maximum value for sine, it goes up to 1, and the minimum value go down to 1, negative 1. So the amplitude is 1. And same thing for cosine. Cosine start with negative 1, goes down to, started with 1, goes down to negative 1, and come back up to 0, and then go all the way back up to 1, and then start going down again. So the amplitude for both functions is also 1 unit in this case. 1 unit in this case. Now let's take a look at another website. Okay, this website shows also has a unit circle here and shows the graph rotation. Okay, so let's go ahead and take a look at sine and see what happened. So when we deal with sine, you have the yellow segment. Now this yellow segment is actually the value. The y value, I'm sorry, not yellow. The red segment is the y value of this point. The x and y coordinate, the y coordinate of this point as the angle rotates. So let's go and try it again. So as the angle rotates, the y values increase and then go up to 1, come back down to 0 at pi, and then so as you can see on the sine graph, as it completed the path, it goes from 0, starting from 0, 0, and then go to pi over 2, 1, and then comes down to pi 0, and then goes down to 3 pi over 2, negative 1, and comes back up to 2 pi 1, 2 pi 0. So that's how sine curves completes its first cycle, its first period, if you want to say that. So let's take a look at cosine. Okay, let me go ahead and turn off sine and look at cosine only. Now the cosine is the x coordinate. If you can see that, if I just stop right here, you can see the green segment represents the x coordinate of this point. So that's exactly what we're doing, is as the point, this is the angle theta. As the theta rotates through the unit circle, this point changes its coordinates. The x coordinate changes. It progresses. So let's go and reset. So you start with 1, At 0, 1, it goes to pi over 2, 0, then it decreases down to pi, -1, then increases back up to 3 pi over 2, 0, and then continue to increase until it reaches 2 pi 1. So this is how cosine progresses. And let's go and take a look at them together, okay? So this will show us both the progression of cosine and sine at the same time. As you can see, this intersection point is pi over 4 because at pi over 4 they have the same value. And here's again, this is another place where they have the same cosine and sine, and they have the same value there. Okay, so as you can see, they actually have the same kind of curve, and we actually call this curve a sinusoidal waves. Sinusoidal wave. It looks like a wave, and both cosine curve and sine curve, they are exactly the same curve. They just have different starting point. So we call them, both of them, sinusoidal waves. And they have very important applications in science, in understanding signals, in understanding light, and understanding waves, and any kind of wave-like behavior, especially in communications, in modern communications, radio waves, signal waves, and things like that. And they are very important. So we'll be working and dealing with that in a little bit later. Now, just a preview, let me go ahead and show you what tangent looks like. Now, tangent actually is the quotient of sine over cosine. So sine divided by cosine. So there's this is the blue segments representing the tangent. As you can see, tangent is very, very different than sine and cosine, because it's a ratio, it's a quotient of sine and cosine, sine divided by cosine. So the graph of tangent is a little bit different, and we will deal with that in our later lessons. Okay, but those two are some websites that we can go ahead and definitely use to help us understand this a little bit more. Okay, and so we have talked about the graph of sine and cosine already. Let's go ahead and just do a little table here to put them in perspective. Okay, put them in a little perspective. Let's do the sine and cosine, and then let's see if we can understand this a little bit more. So the sine of x, okay, so we're gonna say y is equal to the function of sine x, and y here is going to be equal to cosine x. And let's start with 0. So this is the x values. S goes to 0, pi over 6, pi over 4, pi over 3, and then pi, right? So this is the first quadrant, and then we'll go, the next one is 2 pi over 3, 3 pi over 4, 5 pi over 6, and this is pi over 2 actually, pi. So this is the first quadrant. If you want to think about it as the first quadrant, this is the end of the second quadrant. And then if we continue going, this will be 5 pi over 6, 3 pi over 4, so it'll be 7 pi over 6, right? And then it'll be 5 pi over 4, and 3 pi over 4 pi over 3, and then 3 pi over 2. That'll be end of this third quadrant. And then lastly, you will have 5 pi over 3, 7 pi over 4, and 11 pi over 6, and then 2 pi. Okay, so as you can see, let's go ahead and start with this, and it will end at 2 pi. Alright, so sine starts with 0. Okay, at pi over 2 it will be 1, at pi it will be 0, at 2 pi it will be 1 again. I'm sorry, -1, and then 0 again. 2 pi will be 0 again. So those are the main thing you have to understand. Remember, sine goes from 0, increase to 1, come down to 0, go down to -1, and come back up to 0. But cosine goes from 1 and come down to 0, go down, decrease down to -1, come back up to 0, and then we eventually come back up to 1. So cosine has a different progression. But if you can see it, it's a little shifted. You see, cosine, if you go ahead and match this, you see cosine started out a little bit early. Okay, sine started out with 0, but cosine started with 1. But they actually follow the same pattern. You see that? 1 down to 0 to -1 and 0. 1 down to 0 to -1 and back to 0 and back to 1. So if I keep going, you can see that the two functions, they have the same pattern. It's just that they start out at different time. So there's some kind of shift. We actually will call it phase shift. It's phase, P-H-A-S-E, phase shift. So here it started out with pi over 6. You have 1/2. Okay, square root 2 over 2, and then square root 3 over 2. So basically, those are the main values that we were going to pay attention to. But 1, it will do the same thing, but it will go backwards. Okay, so for cosine, it will go down to like this. Then after you go to 1, and then here we repeat. So now we can do square root 3 over 2, square root 2 over 2, and the 1/2. So it's like this is preceding cosine. The cosine first quadrant is preceding the second quadrant of sine. Alright, and then so the cosine of the second quadrant, it goes down, so it becomes -1/2, negative square root 2 over 2, negative square root 3 over 2. And then this will precede the sine value in third quadrant. So here it will be -1/2, negative square root 2 over 2, negative square root 3 over 2. So here, what I would like you to understand is the pattern. Alright, after you get to -1, you can't go down anymore, so you're now coming back up, right? So you can back up to negative square root 3 over 2, negative square root 2 over 2, and then -1/2, and down up to 0. So this will proceed, this third quadrant for cosine will proceed the fourth quadrant of sine. So fourth quadrant of sine will follow the same as third quadrant of cosine. So negative square root 2 over 2, negative square root 2 over 2, -1/2, and then back to 0. And then here, this part will go from 0 to 1, and so it's basically the same as the first quadrant of sine. So it's 1/2, square root 2 over 2, and square root 3 over 2. So if you can see the pattern here, there's a shift offset. And then if you can say, tell me how much is the offset? Well, think about it. The offset is exactly one quadrant, right? One quadrant is 90 degrees, or pi over 2. So that's exactly right. The offset, the phase shift between sine and cosine, is exactly pi over 2. Okay. Alright, so we will go ahead and stop right here. And if you have any other questions and comments, please remember to post it on the comment section. Next lesson, we will go ahead and continue to talk about their graphs, and then we will also mention the graphs of other functions as well, starting from tangent, secant, cosecant, and cotangent. Okay. Alright, we'll see you, hopefully to see you, and you will join us in our next lesson.